All right, so it's not going to be as big as it was, but hopefully you can still see okay. So I'm Scott. I'll be talking about advanced one. I'll mainly be talking about the SCAT data. SCAT stands for Shoreline Cleanup Assessment Technique. Has anyone in the room know what SCAT is? The hands. So pretty good number. Good. I see some SCAT training students too in the back there. So. And what we're going to talk about for Deepwater is really multiple years of survey across the entire area of response. And just a couple other things that SCAT is not, that often gets confused with. SCAT is not natural resource damage assessment. It's not NRDA. It's not really based on aerial or satellite-based types of assessments, and it's not really based too much on forensic oil or chemistry or sediment chemistry. Sometimes those things are coupled with SCAT, but that's not really SCAT itself. So next slide. So what is SCAT? It's a visual ground-based shoreline survey. It can be done on foot. It can be done on ATV. Sometimes it's done from small boats or airboats in areas that are difficult to access. But it's actually what SCAT teams see and record on the field. So it's visual oiling, so grosser oiling levels. And it uses standard methods and terminology. At the end, I'll give you a link to a resource if you want to know more about SCAT and kind of how the method is practiced. SCAT primarily supports oil spill response, emergency response, not the other processes that come later like NRDA and restoration, et cetera. So we document oiling conditions. We identify areas that need cleanup. I could keep going, but you want to? Okay. And SCAT, the information collected by SCAT contributes to shoreline cleanup plans. So next. Once the cleanup is ongoing, SCAT teams monitor the cleanup effectiveness and effect. Is the cleanup working or not? Is it effective at removing the oil? Is it having other detrimental effects you may have not anticipated? Do you need to adjust techniques, et cetera? Once operations or the response thinks that cleanup on a shoreline is complete, SCAT will basically inspect those areas, compare those oiling conditions on the shoreline to the cleanup endpoints that are defined in the cleanup plans, and determine where we are. Do we need to do more? Do we need to back off? Are we done? And oftentimes, in many spills, SCAT will make at least recommendations on when shoreline cleanup is complete. Now, SCAT is used as a data source for other things like NRDA, so it does contribute to NRDA, although it's not NRDA itself. It's also used a lot of times, like a lot of the Gomery studies that involve shoreline areas or near-shore environments will use SCAT as at least a screening method to determine where they're going to put their study sites for different levels of oiling, control versus oiled, et cetera. And then SCAT is often used for restoration planning as well. You can look at what areas had greater oiling, greater effects, what areas need restoration, what type of restoration is needed. And if you're familiar with things like the Restore Act, there's even some specifications in there about how some of that money gets distributed based on the levels of shoreline oiling in different states and different counties and parishes, et cetera. So who conducts the SCAT surveys? This is often not really that well known either, but it's usually a combination of at least 3 people on a team. There'll be a federal agency representative, a state agency rep, and then a responsible party rep, BP, or one of their consultants or contractors. In this case, oftentimes local agencies will go on SCAT teams as well, landowners, federal landowners especially, Park Service, U.S. Fish and Wildlife Service, et cetera, and sometimes other specialists like operational specialists, oil or sediment chemists, archaeologists in some cases if you're near those types of resources. And these agencies listed here were some of the primary ones who were involved in SCAT surveys for Deepwater. Next. So a few definitions. You'll hear me say this one a lot, maximum oiling. So what maximum oiling or max oiling is, it's taking all the survey data together and always for each oiling segment or segment of shoreline determining what were the worst conditions in terms of level of oiling, degree of oiling ever recorded on that segment. And then you add all those up. So that's max oiling. You'll hear that. Then I'll also talk about oiling over different levels over different years, and what that will be is really current oiling. That would be the oiling conditions as of the last or the latest survey done for any shoreline segment. and we'll give you some stats in a time series to look at that. So, and I guess one other note, today I'll be talking about data really spanning 3 years from the beginning of the spill through 2013. These stats are current to the latest peer-reviewed publications that have come out. There's been updates and QAQC done on the database. The current numbers are a little bit different, but they're not that different. These are still representative of the distribution of oiling overall. And there's some additional reports and things coming out, as well as some people working on different data sources, combining those with SCAT as well. So the picture, I don't know if you can't see it very well, but this is a trench or a test pit. SCAT teams also look at subsurface oiling. A lot of the stats I'll be showing you today, either numerically or in graphics, are based on surface oiling. But subsurface oiling was also a big part of deepwater, especially oil burial on the sand beaches. So this is a test pit or a trench. It's hard to see, but at the top of the shovel, there's a layer of buried oil here. Buried oil was a big problem during deepwater. The spill covered a long time period, covered a big area. SCAT teams couldn't always get there quickly enough to document the oil on the surface. It would get buried by sand. Another big factor was during deepwater, the beaches were in an erosional state when a lot of that oil came ashore. So the beaches were eroded, oil came ashore, and then started accreting sand afterwards and got buried very quickly in most cases. From SCAT surveys, we saw burial on sand beaches as much as a meter or even a little bit more in some cases. And some of you, as land managers, are probably familiar with that. So burial is a big part of this, so keep that in mind. There are ways that SCAT takes the subsurface data, which is really point-based, and we can do some spatial modeling to determine the distribution of subsurface oil, but that's not what I'm talking about today. I'm just talking about the surface expression. So this would either have been recorded initially before it got buried, or oftentimes recorded after an erosional event like a big storm when the oil got re-exposed. And I think some of the other speakers may be talking some about that today as well. Thanks. So some other definitions, oiling degree. So extent is the linear extent along the shoreline. The degree are things like you'll hear these summary categories like heavy, moderate, light, very light, trace, less than 1% oiling, no oil observed, or NOAA. That's based on oiling width, cross-shore, so cross-shore width of oiling, the width of the oiling band on the shoreline, the percent cover of the oil within that oiling band, and then the thickness of the oil. And kind of take a look at this picture, if you can, hopefully you can see it. You see pretty wide oiling band there, probably more than several meters, pretty high percent cover, probably at least greater than 50, maybe even 70% cover. And this is a emulsified oil or mousse freshly on the lower intertidal of a beach, and it looks pretty thick. You can probably get a sense of that from the photo. So I'll show you very quickly in a hard-to-read matrix about how this works. So on the top left, and the very top, we come in with the oiling width across the shoreline. Use that picture as an example to keep your memory there. So is it wider than about 2 meters? Yes. Is the oiling, in that broken or continuous category, at least more than 50%, right? So it would be heavy. You take that heavy category overall back into this, down into the second chart, coming right here at heavy. What was the thickness of that oil? Was it at least a tenth of a centimeter thick? I'd say probably yes. So you come into this box here, so heavy oiling. So what that was a good example of would be heavy oiling, initial oiling on a sand beach. I think we'll leave it there because it's probably hard to read, but it gives you an example of how we get to these summary categories. So next. So I'll give you some stats now by the numbers, and what I'll do is I'll go through some of these and kick out numbers. Some people absorb things better that way, and then I'll follow it with a bunch of graphics, maps, charts, et cetera, for folks who are more inclined to kind of absorb things that way. So maximum shoreline oiling across the Gulf. Remember what maximum was, the worst case oiling observed along every segment of beach or shoreline that was surveyed. So 1,773 kilometers, over 1,100 miles, just based on SCAT surveys Gulf-wide. SCAT did not operate in Texas during the spill. State of Texas did document some trace oiling in their area, about 58 kilometers. If you add that to the mix, it's not really SCAT data, but it's SCAT-like, it would get you up to over 1,800 kilometers. Now, again, I mentioned this, I think, already. There are other data sources as well, other types of surveys that can be merged, combined, integrated with SCAT to produce other oiling statistics. And some of that's being done as well, and you'll probably be seeing, you probably have already seen reports and stats kicked out on those. I'm just really speaking about SCAT today. So, break it down by shoreline type or shoreline habitat. There were 900 kilometers of sand beaches Gulf-wide oiled. That was about 51% of the maximum oiling overall. Almost 800 kilometers in coastal wetlands, mainly salt marsh, also some mangrove areas, and lower salinity marshes. And then a little bit more than 70 kilometers on some other shoreline types like riprap, seawalls, bulkheads, etc. Again, picture of some buried oil on a beach. I think that's probably from Pensacola Beach, if I remember. So next slide. Some other stats for you. Now I'm breaking it down, maximum oiling by state across all the shoreline habitat types. And I put Florida on top because I figured most people would be from Florida, and then just kind of went geographically across the Gulf. So almost 300 kilometers of oiling in Florida, that's about 16% of the total. Alabama, about 150 kilometers. Mississippi, about a little bit more than 250, and then Louisiana, over 1,000 kilometers oiled. So most of the shoreline oiling was in Louisiana, but still significant amounts in the other states. Florida and Mississippi pretty similar. Florida coming in, I guess, second if you're ranking them. And then this picture is something else I wanted to show you. And then we're going to talk about this some later today when I think Suki's going to cover this. So this is, you can see these guys in the water in the background. During Deepwater, there was also oil deposited, not just on the beach, but also in the nearshore subtidal. That may have been oil that picked up sand in the surf zone or oil that picked up sand on the beach. That oil then transported back into the near shore and settled, sometimes accumulated in what people would call tar mats. It wasn't really tar or oil mats. It's really a form of surface oil residue, oil mixed with sand, then deposited in the near shore. Similar thing was buried on the beaches in a lot of cases. These things would break up, and I'll show you some other pictures, into tar ball sized pieces of material, and I'm okay if we call them tar balls. It's easier to discuss that way. What they really are SRBs, or surface residue balls. They're surface oil residue in tar ball sized pieces. They're mostly sand, but they're saturated with that mousse material and turned into kind of an oil and sand mixture that's not real cohesive, so it breaks into smaller particles. I think some of the other speakers will talk in more detail about that as well. So let me just jump back one slide. So these are the maximum oiling stats across all shoreline types, and jump forward one. Now we'll talk about maximum oiling just on sand beaches, so sand beaches only, again by state. And you see a little bit different pattern here. So almost 300 kilometers in Florida, and it jumps up to 31% of the sand beach oiling. Alabama, a little bit more than 130, Mississippi almost 200 kilometers, and Louisiana almost 300 as well. So Louisiana and Florida in terms of sand beach oiling, pretty similar. So what's that tell you? A lot of the oil in Louisiana was in coastal wetlands, and we'll show you a graphic on that later. This is a photo of some cleanup going on with mechanical equipment in the lower intertidal and probably also in the shallow subtidal, where they're trying to get up some of those more extensive oil mats that were in the lower intertidal and shallow subtidal. And we may hear some more about that as well, but pretty intensive work to get those up. And what was the problem there is if you left those in place during storms, they get buried, unburied, buried, unburied. During storms, they get unburied. Wave action would work on those, break loose chunks of them or pieces of them. Those would get thrown up on the beach. You'd see that after big storm events, and probably a lot of you may have experienced some of that. So next slide. So here I'm going to give you a time series. So this is across all 3 years. Again, maximum oiling, 1,700 kilometers. 1 year later, in 2011, you saw that amount decrease by a good bit. Decreased a little bit more in 2012 and changed a little bit in 2013. So you see a big change initially and then a slower change, and I'll come back to that. If you look at just 2013 by shoreline type in 2013, 469 kilometers of that oiling was on sand beaches, a little bit more than 150 on coastal wetlands, and then some on other shorelines as well. This is an example of what those SRBs, and again, I'm okay with, we call them tar balls, but surface residue balls, basically sand and oil mixtures in tar ball sizes that would wash up on the beaches, either getting exposed when sand was eroded off the beaches if it was buried, or thrown up from nearshore areas. And this was often in trace amounts of oiling over long time frames. Next. So we're going to break it down now in some of those degree classes. So heavy to moderate oiling some of the higher oiling levels, like you see in this picture and like I showed you in the previous picture when we walked through that example of how the matrix works. Summary oiling conditions, heavy to moderate. At maximum oiling levels, 250 kilometers. 1 year later, it dropped down to 28, so a pretty big change in the heavy oiling categories. Didn't change so much over time after that. It went down, but still more slowly. And if you look at 2013 and we look at the other end of the spectrum, look at the light to trace oiling on beaches, 90% of that, 96% of the oiling on sand beaches in 2013 was in those lighter categories. And of that, 88% was trace oiling, so less than 1% cover. Those are those SRBs or tar balls being continually distributed and reworked on the beaches, picked up by cleanup crews, and then additional ones would become exposed on the beaches. Next. So I'll compare Deepwater to some other major spills and some other recent spills. So Deepwater Horizon, we've already talked about max oiling there, so let's talk about, just real quickly, Exxon Valdez in Alaska. Much less volume of oiling, but a little bit greater shoreline kilometers that were oiled. So it's not always the amount of oil that relates to how much ends up on the shoreline. The Gulf War in the early 90s, and this is just the Saudi Arabia component, much higher volumes of oil, or several multiples of Deepwater in terms of volume, but less shoreline oil. One of the differences there is the width of shoreline oiling there in the Middle East is very large, kilometer or more in some cases, where we're talking meters to tens of meters during Deepwater. But just different nature of oiling in different environments. Still, Deepwater ranks among the larger marine oil spills, you know, in history, especially when you look at the shoreline oiling. It's probably at those numbers pretty comparable to Exxon. Some recent spills you may have heard in the news, if you remember, Texas City Y in Texas, near Galveston and spread on down the coast to the south. Pretty big spill, got a lot of news coverage. A lot of us that were emergency responders got mobilized to that one as well, and I worked that one as a SCAT coordinator also. 260 kilometers, still respectable amount of oiling, but several multiples less than Deepwater. And then most recently, you're probably familiar, you've seen on the news the Refugio spill near Santa Barbara. California, that so far has recorded 120 kilometers of maximum oiling. These pictures are just to show you what a little different spill can look like. This is Texas City Y. I keep thinking I have a pointer. Heavier oil looked a little bit different. Again, deposited on the beaches, very similar. And in most spills with oil on beaches, not just Deepwater, you get a buried oil layer. Same kind of thing happened there at Texas City Y. Next. So go through some graphics now if you're more inclined to absorb things this way. This is maximum shoreline oiling across the Gulf, and I'll kind of work left to right, I guess, west to east. So you see heavy oiling, the red, as far west as Marsh Island on the beaches in Louisiana, a lot off of Terrebonne and Barataria Bay, a lot of red there, a lot of heavy beach oiling, some on the Bird's Foot of the Delta. That island offshore there are the Chandeleur Islands, a lot of heavy oiling there. I'm running a little slow. On across the Gulf into the western panhandle had heavy oiling, and then oiling even at trace levels all the way over to St. George Island and Dog Island in Florida. So we'll show 1 year later, big changes. Mainly light oiling, trace oiling, so no oil observed in the eastern panhandle, and still some heavy oiling in places. The Chandeleurs doesn't change because we weren't able to resurvey that. 2 years later, you won't see a big difference on the maps, a little bit, and then 3 years later, a little bit different, but not too much different. So next, I think I'll skip through these just real quickly. This just shows Barataria Bay, showing some of the Barrier Islands in Louisiana, how they changed over time, 1 year later, 2 years later, and 3 years later. And next slide. Some graphics. We already went through over some of these numbers along the top. That's by state and by maximum oiling, and then each year. See a lot of oiling in Louisiana. A lot still in the other states, and the decline over time into trace oiling mainly. On the bottom, by habitat type, marsh, a lot of marsh oiling in Louisiana, a lot of beach oiling across all the states. The categories were much lower. Next slide. This just kind of shows how things change over time. The heavier oiling categories, even into very light, dropped off very quickly after the first year and into the second year. This trace oiling level in light green, though, it declines, but much more slowly. And you probably even can find SRBs on some of the beaches now if you're walking those beaches. Next. The wetlands a little bit different, fell off a lot more quickly and didn't have that persistent trace oiling that lasted for a long time. Next. So kind of wrap up. So I said this already, Deepwater ranks among the biggest in terms of shoreline oiling. Greater than 50% decline in oiling extent in the first year, a little bit less so for the beaches, a little bit more persistent on some of the beaches. That heavy to moderate oiling category dropped a whole lot, especially after that first year. Next. These oiling declines were, a lot of it was through natural attenuation, weathering, biodegradation, natural removal processes, physical processes in the near shore and on the beaches, and also shoreline cleanup activities, manual cleanup and mechanical. For example, of tilling that was done on the beach. Next. But over time, we saw that flattening rate of change. Why was that? I mentioned some of these things before. That buried oil would periodically, after storms, get re-exposed, redistribute oil in the shoreline that had to get picked up. The oil in the near shore, that soup you'll talk about, same type of thing, get exposed, get eroded from the near shore, transported onto the beaches themselves. And also, we had some cases of persistent oil in some coastal wetlands, especially in Louisiana, where we had really heavy oiling. Some of that oil is still present in those marshes in a weathered state. Next. So I think this is the last slide, or almost the last slide. Just a couple examples of where we are now or where we went after a lot of these slides were put together. Louisiana did not have as extensive cleanup early on or as intensive as some of the eastern portion of the area response. They were concerned about using mechanical equipment, about excavating oil. Louisiana was worried about losing sand and their high erosion rate that they had even beforehand. Okay. So basically, I can keep going. They, later on, they started an intensive program to identify where that buried oil was and remove it. That continued through most of 2013, even beyond these slides. Florida is an example. I think the response ended there in 2013 officially, but the state of Florida kept on doing post-response monitoring through the end of 2014. They continued to find trace oiling on most of the beaches, especially in the eastern panhandle, Scambia, Santa Rosa, Okaloosa County. Finding, again, those tar balls or those SRBs coming up periodically on the beach at low levels. Crews would go out and pick those up. And they even found some of those near-shore subtidal mats that had been missed during the main response. And those were actually cleaned up. One of them, I think one of the most recent ones was a couple thousand pounds, I think, is that right? Were actually removed from that mat. Those mats were generating oil on the beaches periodically, so they went out and surveyed for them, found those, and then did the removal actions. Next slide. I think we'll hear some more about what's going on in Alabama even now from some of the other speakers, so that'll be good. For more information, and we can circulate this later, it's probably hard to get down because some of the links are long, but a lot of this information is summarized in a +1 paper. This is Journal +1. IOSC is the International Oil Spill Conference. There's a more recent update there. If you're interested in looking at the SCAT data themselves, you can go to NOAA's IRMA website. If you're more interested in SCAT and those methods that contribute to all this, you can see the SCAT Shoreline Assessment Manual online as well. And the last slide is just acknowledgements. Sorry if I went a little long, but basically just recognizing the agencies and some of the consultants who were involved in putting all this together.